Hi friends, here in this video I'll be explaining a problem on simulation. So let's get started. Now here is the question, the problem on simulation. A company manufactures around 200 mopeds. Depending upon the availability of raw materials and other conditions, the daily production has been varying from 196 mopeds to 204 mopeds. So the rate of production is given, that is either on any given day 196 mopeds or the range may be up to 204 mopeds are manufactured, whose probability distribution is as given below. The probability of the production is production per day 196 mopeds would be manufactured. That probability is 0.05. If you want to convert it into percentage, that is 5%. 197 mopeds, that is 0.09. 198 moped, that is 0.12, and the last one 204 mopeds, they are manufactured or produced at a probability of 0.06, or we can say 6%. So after the probability, the finished mopeds are transported in a 3-storied lorry. So the mopeds are transferred that can accommodate only 200 mopeds. So this is the condition, limiting condition, we can say, that the lorry has only space for 200 mopeds. So at a time it can carry only 200 mopeds as mentioned. Next, using the following 15 random numbers. So the random numbers are given here. These are 15 random numbers starting from 82 ending up to 10. Then simulate the process to find out. We have to simulate this. What will be the average number of mopeds waiting in the factory? So that is one of the question, that is we have to give the average number of mopeds which are waiting in the factory. What will be the number of empty spaces in the lorry, and we have to just explain how many empty spaces would be there in the lorry. So once the question have been understood, we can directly start with the solution part. Now into the solution. The first part would be, I'll be explaining how to select or to get the random number interval. So the first step would be, the random numbers are established as below. So here I'll be explaining how to establish the random numbers. Counting the total production days. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now here I have drawn 4 columns. In the first column, write down production per day. Production per day. In the second, probability. Next, cumulative probability. And the last one, random number interval. Now production per day, it is starting from 196 and goes up to 204. So here I have written the production per day 196, 90, 197, 198, 199 up to 204 and the probabilities which are given. So here 196 is having a probability of 0.05, 197 0.09. At the end 203 is having a probability of 0.08 and 204 is having a probability of 0.06. Next I'll find cumulative probability by adding. So starting with 0.05, it will remain as it is. Then in 0.05 add 0.09. So just go on adding. It is 0.14. Then in 0.14 add 0.12. So that is 0.26. Next in that add 0.14, 0.40. In that, add 0.20, so that is 0.6, then 0.15, next 0.11, then 0.08, 0.94. At last, in 0.08 add 0.06, that is 1. Now after getting the cumulative probability by adding all the terms, random number interval is selected by considering the cumulative probability, which is in the form of decimal. I'll convert it into percentage, like for example 5%. So the random number interval, first one is starting from 0 and 1 less than this number, which is 5, exactly 5%. So 1 less than that, it means it is 4. Next interval will start from 5 and it will go 1 less, it means this is 14% probability, so it means it is 13. Next, from 14 it will start and go up to 1 less than this value, so it is 26, so here this would be 25. Next, from 26 it will start and go up to 39, because here there is 40. Then it will start from 40 and go up to 59. Then start from 60, go up to 74, 1 less than this 75. Then we have 86, so it will start from 75, go up to 85. Next, there is 94, so it will start from 86 and go up to 93. At last we have 1, so it will start from 94 and it will go up to 99. So in this way the random number interval are selected. Now I can get the final table, and since 15 random numbers are given, here I would be plotting this for 15 values. Again we have to draw a table. So we have the first column called as the day number. Next would be the random numbers, 15 are given. Then production per day. Then number of mopeds waiting. Next, number of empty spaces in the lorry. Now as 15 numbers are given, so I'll write the day numbers starting with 1. So writing the number of days, then the random numbers. Random numbers starting with 82 up to 10. This I'm just copying it and writing over here. So it is 82 and then so on. So these are the 15 random numbers given. Now production per day. Look at the random number. The method which I am showing here. The first random number is 82. Now go into the random number interval column. Into this column, see where 82 comes. I'll explain that 82 is there in the range of 75 to 85. So from 75 to 85, when we go back, here the production is of 202 production per day. So look into the interval, it is 82 between 75 and 85, and then in the same line go up to the production. I am getting the answer as 202, so I'll write 202 over here. That is the production per day. Now since the production is 202, it means 2 mopeds are manufactured extra, because here what the condition is given is that the lorry can transport 200 mopeds at the most. It can accommodate only 200 mopeds. So at first 202 are manufactured, so the number of mopeds waiting would be 2 because only 200 can go. So here 2 remains. And the number of empty spaces in the lorry, since the production is 202, 200 can be transferred in the lorry, so there are no empty spaces in the lorry. And the number of mopeds waiting, they are 2. Next, the next random number, I'll explain it by just taking it. Whatever is done, I'll just go on taking. The first random number has been done. Second, it is 89. Now see, 89 is there in which range? We can see that 89 is in the range of 86 to 93. And 86 to 93 will correspond to 203. So the next number of mopeds manufactured is 203. So take this random number. And now again we see 3 mopeds are manufactured extra. So in that case, what we can analyze is, on day 1, 2 mopeds were there which were extra. On the second day, 3 mopeds. So 2 plus 3 total is 5. So here I can just elaborate and write that it is 2 plus 3, which is equal to 5. So now 5 mopeds are there with us, and again the number of empty spaces in the lorry are 0 because the number of mopeds are manufactured more than 200. So 200 can be easily transported in the lorry. Next is 78 random number. So go into the random number interval. 78 is again between 75 to 85. Go back up to here. Again the value is 202. So the production per day is 202. Now also we can see the number of mopeds manufactured are more than 200. So 200 would be transferred into the lorry. So there are no empty spaces in the lorry. And again 2 mopeds remain. So previously there were 5 remaining, and now again 2 are remaining. So that means the total mopeds left, they are 7. Then select the next random number, which is 24. Now 24 is corresponding in the interval between 14 and 25. And when I go back into the production per day, it is in 198. So now the production per day is 198. And in order to transfer the mopeds in the lorry, we should have 200 mopeds. Here 2 less mopeds are there. So out of the 7 which are remaining, 2 will be given over here. So that becomes 200, and again it will go into the lorry. So no empty spaces in the lorry. Out of 7, 2 were sent. So what remains is 5. Now we have 5 mopeds which are waiting. Next, the next number is 53. So again go into the interval and see 53 is there in which random number interval. So 53 is there between 40 and 49. And when I go back, it is up to, here there are 200 mopeds, that is the production per day. So I am writing 200. So exact manufacturing has been done, that is 200. So all the mopeds would be transferred. So again no empty spaces in the lorry here, and these 5 mopeds, they remain as it is because now we are not taking any mopeds from here. Then the next value is 61. Go into the random number interval and see that 61 is between 60 to 74, and this will correspond to 201 production per day. So now again 1 moped is manufactured extra, so it is 201, and out of 201, 200 would be transferred in the lorry. So no empty spaces again in the lorry, and 1 moped is extra. So 5 were remaining before. Now 5 plus 1, that becomes 6 mopeds. Then 18. Again go into the random number interval and see that 18 is in the range of 14 to 25, and then there are 198 mopeds as we see here, production per day. So 198. Now in order to transfer them into the lorry, we need 200 mopeds. So 2 would be given from this 6, so that it becomes 200. So again there would be no empty spaces in the lorry, and from 6, 2 have been subtracted. So here we have 4 mopeds which are still left, they are waiting. Next, the next random number is 45. So again go into the random number interval and see 45 is in the range of 40 to 59, where the number of mopeds were 200. So exact 200 have been manufactured. So all 200 mopeds would directly go into the lorry. So again there are no empty spaces left, and these 4 mopeds are waiting still left. Then the number is 4. 4 is, we can see it is in the first interval, that is from 0 to 4, and that corresponds to 196 production per day. So now it is 196 mopeds which are manufactured. To make it 200, we will give the mopeds which are waiting. 4 mopeds were waiting, so we will add them over here. 196 plus 4, that is 200. All 200 would be transferred. So now the number of mopeds which are left, they are 0. The number of mopeds, they are not waiting. Now we have to start it fresh. That is, no mopeds are waiting now up to the 9th day. Then go to the 10th day where the random number is 23. Go into the interval. See, 23 is between 14 to 25 and it is having production of 198. So now the production is 198 and we don't have any mopeds in the waiting column. So it means now there would be 2 places empty in the lorry because it has to transfer 200 and here only 198 are there. So that means 2 spaces are empty and no mopeds are waiting. Then the number is 50. 50 is in the range of 40 to 59, and when it is 40 to 59, that corresponds to 200 mopeds as we see here. So I am writing again 200. Now exactly 200 would be transferred, so no mopeds waiting, no empty spaces. Then 77. 77 is in the range of 75 to 85, which is having a value of 202. So now 2 mopeds are manufactured extra. So 202, out of which 200 would be transferred into the lorry. So no empty spaces in the lorry, but 2 mopeds are waiting now. Next, after that the number is 27. Go into the random number interval. 27 is between 26 to 39 and the production per day is 199. So it is 199. Now 1 moped would be given from here, since we have 2 mopeds and we want 200. So 1 moped would be given. So 2 minus 1, that is 1 is still remaining, and again there are no empty spaces because 200 would be transferred. The next random number is 54. So go into the random number interval and see that 54 is in between 40 to 59. Again the value is 200. So 200. Now this moped will remain as it is because already 200 are there, they would be transferred, so no empty spaces. Finally, the last number is 10 and that corresponds to between 5 to 13. The number of production is 197, so it is less than 200. So we have 197 production per day. And now to make it 200, the number of moped waiting with us, we have only, here there is this 1, and now 197 are there, but moped waiting they are only 1. So when I add in 197, I add 1, so that is 198, means it is less than 200. It means 2 empty spaces would be left in the lorry because we can't still make it as 200. So now the number of mopeds waiting are 0 because this 1 goes over here. So we have 198. Now once we have reached up till here, the question was what will be the average number of mopeds waiting in the factory. So average number can be calculated from this. So for that we have to take these numbers. I am just marking them. Here we have 2, then 5, 7, 5, again 5, then 6, 4, 4, 2, 1 and 1. So we have to add up all these numbers and divide by the total number of days, that is 15. So therefore the average number of mopeds waiting in the factory are I'll write all those values. Dividing by the total number of days. So the average number of mopeds waiting comes out to be, I'm getting my answer is 2.8. So that's the first answer. Next, the number of empty spaces in the lorry. For that, we have 2 plus 2 divided by the total number of days. So that is the average. So therefore, average number of divided by total, and my answer is, it is 0.27. So in short, that was a problem regarding the simulation problem. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.